All right, everybody. Welcome to day one of Math Made Easy. Today, what we're going to be doing is we're going to be going over something called the Pythagorean theorem. What is this? Well, the Pythagorean theorem is a way for us to solve for the sides of a triangle, but this only works for a special kind of triangle called a right triangle. So let's go ahead and get started with filling in our notes. So a right triangle has what's called a right angle. The side of the opposite of the right angle is called the hypotenuse, or sometimes just called the longer side. So let's take a look at this picture and let's identify those pieces. So first thing, I always look for my right angle. That's this guy. How do I know? This box means right angle. So anytime I see that box, I should automatically assume that this is a right angle, 90 degrees. So the other two sides, and that's going to be this side and this side, are short sides, right? Because they look much, much shorter than this one that I'm going to highlight here in blue. So those two orange sides are significantly smaller, right? So these are what's called legs. This guy's a leg here too. The longest side is also called my hypotenuse. And it's the longest side of my triangle. It is opposite to my right angle. So how do I remember all of that? Well, whenever I come across a right triangle, I always look for my box, and opposite to it is my hypotenuse. Most of the time, what we like to do is we like to name these with letters. The one that's the longest is always C. And my legs, A and B. It doesn't matter who's A, who's B, as long as the legs are A and B. Okay, next part. So we use the Pythagorean theorem, which is a squared plus b squared equals c squared, to find the missing side lengths of a triangle, where c always represents what's called my hypotenuse. So let's go ahead and take a look at an example. So here I have a right triangle. How do I know that for sure? Well, little box down here. So that means this is definitely a right triangle. I'm going to look opposite to it, and that's my hypotenuse, C. 5 and 12 are both legs because they're on either side of the 90-degree angle. So I'll just say A and B. All right, let's write in what we know. A is equal to 5, B is equal to 12. C is, I don't know. So that's who I'm looking for. All right, let me go ahead and write in my formula. Every time, I always start by first writing in my formula. I'm going to highlight these guys by color just so we can see where they're supposed to be plugged in. If you notice, I still have to leave something for C because I don't know what it is. I'm going to leave it as the letter C. So 5 squared plus 12 squared equals C squared. Okay, so if I type that 5 squared into my calculator, or if I remember that whenever I see 5 squared, that means 5 times 5, I'll get 25. 12 times 12 is 144. Now, if I take a look at this, this almost looks like a very simple equation that I've already solved before. So what am I going to do? I'm going to go ahead and combine like terms. So 25 plus 144 is 169 equals c squared. So how in the world am I going to get that c by itself? Let me go ahead and highlight that because that's what I need to get by itself, but it's got that square there. What's the opposite of square? Well, it's called a square root, okay? So square root. Over here, that just cancels it out and leaves me with the c. I can type in the square root of 169 into my calculator and it'll give me an answer. I can also say, if this is a perfect square, what number times itself equals 169? Well, let me think about that. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 11 is 121, 12 times 12 is 144, and 13 times 13 is 169. So 13 times itself makes 169, which means the square root of 169 is 13. Okay, let's take a look at the next one. So here they're asking, what is the distance across the pond? Well, they're doing this on purpose to kind of confuse us, right? Because they have all these crazy drawings and all kinds of things here. But really, I'm just looking for this dotted line, this purple part. So let's go ahead and label these. I see my 90 degrees here, which means opposite to it is going to be my C. Doesn't matter who's A or B, so I'll just write those in. And let's write out my formula. Okay, let's go ahead and fill these in. I'll color coordinate just to help us keep track. And again, we're looking for C here. So A squared plus B squared equals C squared. So let's go ahead and try and simplify those. 6 times 6 is 36 plus 8 times 8, 64 equals C squared. If I combine like terms, 36 plus 64, I get 100. And again, when I'm doing this, my last step should always be square root. So if I find out what the square root of 100 is, 10 times 10 is 100. So the square root of 100 is 10. My answer is C. Is 10. All right, example number 3. The foot of the ladder is placed 5 feet from the wall. If the top of the ladder rests 13 feet high off the building, what is the length of the ladder? Okay, so first things first, let me just draw a triangle here. Okay, so this is my ladder, and they said it's 5 feet away from the building. I'm going to say over here is my building. 5 feet away from the building, and it's 13 feet high. Okay, so I have a few different things here. Let's write them in. I have my 90 degrees. It's going to be my ladder. A and B, doesn't matter which one I put. Let me write out this equation now. So I'll go ahead and say 5 squared plus 13 squared equals C squared. 25 plus 169 equals C squared. 194 equals c squared. Let's take the square root of both sides. C equals, this isn't a perfect one, so I'm going to type this one in my calculator. 13.92. And there's my answer. Number 4. The length of the computer screen is 15 inches. The width of the computer screen is 8 inches. How long is the diagonal? So let's just draw something that looks like a computer screen, 15, 8, and they said diagonal. So that means that this guy's got to be my 90-degree angle, my right angle, which means opposite to it is C, the diagonal. I'll just label these as A and B. All right, let's write out that formula again. So let's plug in A, B, C. I'm looking for C again. So I'm going to go ahead and use my calculator because I don't know what 15 times 15 is. So this is 64. 225. Let's go ahead and combine like terms. And I'm not sure if that's a perfect square or not, so I'm going to use my calculator. And surprisingly, it is. So the diagonal of that computer screen is 17. So I want you guys to go ahead and get started by first looking at these two problems and then moving on to these. Now, these problems are going to be very simple. I kind of took out all the words and all the extra stuff to make it super easy and simple for you. So whenever I look at a problem like this, first thing I'm going to do is draw a triangle. I'm going to put in my right angle, and whoever is over here is going to be my C, always. Whoever's over here is going to be my B, always. And whoever's over here is going to be my A. So this is 8, 10, and A. I don't know A. So whenever I write this into my formula, A squared plus B squared equals C squared, I can fill in B and C, but I don't know A. And that's who I'm looking for. So I'm going to go ahead and solve this one. A squared plus 64 equals 100. Let's go ahead and get that A by itself. Okay, take the square root to get rid of that square. And I find out that A is equal to 6. So I would go ahead and write it in here.